Well, I would like to extend my thank yous to the organizers first for putting together a fantastic program for today. And of course, also thank you for inviting me to speak to you today about the environment, sustainable consumption, as well as turning back to population and the urban transition. The motivation behind our work is the relative lack of research into environmental impacts of demographic change. And by demographic change, I don't only mean population numbers, but also the dynamics behind the population. That is, how people move from urban to cities and possibly back between countries, but also the way we form our families, what kind of household structure, and how long we live. We find that media coverage has been limited to population growth and aging, and rightly so, to some extent, and the related economic, health, and social issues. However, at the same time, perhaps overlooking some of the environmental issues at hand. And at the same time, as we've already heard, the global urbanization of population is a reality. And this is what it looks like at the moment. According to the most recent World Urbanization Prospects, that is the 2011 revision, we have here the global map of urban percentage of population overall. The blue colors indicate this, as well as then the size of cities, major urban agglomerations depicted by the circles. And again, the darker the color, the bigger the agglomeration, so that the red dots indicate cities of 10 million or more in population. And if we compare this map to their most recent, the UN most recent projections of how the urban landscape is changing, we see this. So if we just go back quickly, the lighter blue color changes to a large extent darker, and you see a lot more red dots, especially in Southeast Asia, but also in the Americas. And this is the situation projected in the year 2025, quite close to where we are now. So in our view, the drivers or major drivers at least, for environmental change are urbanization, for one. That is, there are differentials between urban and rural areas that have to some extent perhaps been understudied. And then population, not just the numbers, but the structure of population. What size age groups are, how do the population pyramids look like, and how does this propagate through cohorts? And then consumption. Last but not least, we find that our expanding lifestyle is in fact a huge driver. It doesn't only drive all sorts of consumption, but also, for instance, carbon dioxide emissions through our energy consumption. And we've seen already projections that show alternative population and consumption paths that could have major implications for the impacts on the environment. And we'll now look at that a little bit more closely. Here we've studied comparing USA and India, the two countries' demography trend over 100 years together with their consumption behavior. Now this is energy consumption for which we use the proxy CO2 emissions. So if you first concentrate on the top left image, where both fertility and consumption of energy or CO2 emissions are kept constant, you find that already at the outset, USA, despite its much lower population, has a fourfold head start compared to India. However, as you progress through the simulation, where fertility obviously drives population increase and hence also consumption, you see that in all these different scenarios, the two lines do converge. But to what level they converge is the question. And that depends on how the population pans out and how our consumption pans out in the next decades or even century. So how do we fit urbanization into all of this? We've already looked at population and consumption at a gross level, but we want to distill that into lower disaggregation and including urbanization. So what we want to do is capture the difference in urban and rural fertility, mortality, and consumption. We use data for urban and rural fertility and mortality rates separately, and we get these from national sources. So a lot of countries do record these differentials already, but of course, the further south you go, it sometimes gets a little bit more tricky to find the data. Then we also capture various consumption metrics, for instance, vegetable and meat consumption, in addition to the shown CO2 emissions data. Now, these consumption data we tend to get from cross-national sources, such as the FAO or IPCC, because we want them to be comparable. So we want to ensure that the way the data has been collected is comparable across the countries so that we can do comparative studies in the end. However, then obtaining urban-rural differentials becomes a little bit more tricky. So to obtain that differential, we then exploit sort of national micro-studies where these differences have been looked at on a sort of national scale, and then adopt those differentials into our consumption data. And the countries that we are studying and have studied so far are India, USA, China, and Mexico. Now, this is what the Indian rural versus urban population looks like for the coming 50 years, if everything stays as it is now. So basically, if consumption stays level and fertility stays level, you see this differential between urban and rural population impact, if you like. So in the subsequent images, the solid line is always the urban population or urban population and consumption impact line, and the dashed line is then the rural counterpart. So we already see that, in fact, the urban population of India is pretty much flat. It means that fertility there has actually gone down significantly and is at rather low levels at the moment, and hence the differential between urban and rural, although rural populations also tend to have slightly higher mortality rates. Now, if we turn to CO2 emissions, there are here two different scenarios depicted. The black lines are essentially the same as on the previous slide, so where the CO2 emissions data stays at the current level, set at year 0. And then the purple line indicates a projection where the consumption rates increase according to scenarios obtained from the YASA greenhouse gas emissions database. So what we see here is in effect, the demographic differential is increased as the consumption increases. Now, if you look at meat consumption, the story could be slightly different. Again, the solid line is the urban consumption. And as you can see now in the beginning, it's at a higher level than the rural one. Now, if you then propagate the rural according to its static consumption level, static population, you see that the paths cross at about 40 years from now. However, I made another scenario where the meat consumption and fertility both converge to the urban levels along the 50 years time span, meaning that fertility in the rural areas goes down to the urban levels and the meat consumption goes up to the urban levels. You see that, in fact, the impact is huge. Again, it seems that the consumption increase is a huge driver. The same you can do for instance, vegetable consumption, and here just the y-axis changes compared to the previous slide. The effect remains the same. Consumption convergence has a major impact on the environment. So basically, comparing sort of the Western countries to the global South, we found that the rural-urban energy, for instance, energy consumption difference, depend highly on the GDP and stage of development or urbanization. As we've already heard, this transition happened in the West about a century ago. So those two things can't really be compared one-to-one. However, what we are finding in the global south at the moment is that the urban fertility is really quite low. And it's very low in India at the moment. And I expect the same trend is happening elsewhere. As the levels of urbanization, however, rise, because there is still huge potential in South and East Asia for urbanization to increase, we can expect the urban population fertility decline to basically drive national fertility rates down as well. Then again, rural energy consumption is more sustenance consumption than in the cities, perhaps. Again, there's scalar issues, as we heard Andres mention earlier. But also there's another issue which is quite difficult to analyze, and that is the effect of dirty energy sources or less efficient energy sources. And especially in the global south, in the rural areas, you have less access to the cleanest energy. And hence, in fact, you pollute more than you sort of get in terms of energy equivalent. So it seems that the rural populations, in fact, emit more, although they don't get as much energy equivalence for the pollution they create. Then again, in China, for instance, according to some of the micro-studies we've studied or analyzed, urban energy consumption has a much stronger leisure component. And of course, that's quite hard to take out of the equation as well. So just to wrap up, I would like to use the words of the Royal Commission on Environmental Pollution that was published here in the UK in 2011. Policies to influence behavior and consumption may be more effective than any attempt to constrain or even reduce population size. Thank you.
There should be a couple of microphones in the room. So there's 2 people, I believe. Yes. So if you have a question, please raise your hand and you will receive a microphone.
Hi, my name's Emily King. I work for ERM, and I've got a question about the IPCC reference that you gave. And I think you referred to it in terms of cross-national sources for consumption data. And I'm just wondering how far your work has looked at the impact of climate change on the urban-rural divide, any kind of reverse effect on urbanisation, and also how climate change adaptation will affect availability of resources such as meat and vegetables.
Well, I'm afraid we haven't had a chance to look at those effects yet to the extent that you describe. The way we currently use the consumption data is strictly through the CO2 emissions data. So climate change per se is slightly beyond the reach of the study. However, I do work on adaptation studies outside of the scope of this study, and I can assure you that these things are very, very tightly connected. And if we're able to pull the parallels from this study to sort of, for instance, land use change, then I think adaptation would become a significant part of that. Thank you.
Thank you very much for that. Did you consider, you talked about fertility rates. Do the death rates come in somewhere as well?
Yeah, absolutely.
It wasn't, sorry, I wasn't quite clear. The other thing was, did you include potential rises in, or rather reductions in persons per household? Because there has been some evidence done here, work done here, to show that particularly the rise in the proportion of single-person households is in fact contributing to increases in resource consumption per person.
That's a very good point. However, it's slightly contested, to be perfectly honest. And it also depends on, for instance, the age of the household, the household lead person. So household effects are something that we definitely considered when we put together this, first of all, the proposal and then the study. And to be perfectly honest, we made a conscious decision to look at per capita CO2 emissions rather than household emissions, because I looked into the UK case, for instance, where household emissions data is very well recorded, but it's not so everywhere else. So, for instance, for the Global South, it's quite tricky to maybe capture exactly the household level energy consumption data. Of course, you could make various estimates. But for this study, we remained at this kind of macro level. However, we are thinking about including households in further analysis.
We could fit one more question if there is one.
Just to point out that Emma, there's a small grant we made for global health on determining the causes of death, because 2/3 of deaths in the global south are not adequately explained. The causes of death are not known.
Mm.
So I would encourage you to link up with the global health people on that one.
I'll look it up. Thanks.
Okay, thank you very much.